This next example problem is number 72 on page 32 of the textbook. It reads, if a Cessna 172 requires 20 seconds to reach liftoff speed, to reach its liftoff speed of 120 kilometers per hour, what is its average acceleration? Okay. So, identify, first step, we carefully read the problem. Second step is identify what the problem is asking us to find or solve for. So it says, if a Cessna 172 requires 20 seconds to reach its liftoff speed of 120 kilometers per hour, what is its average acceleration? So it's asking for us to find its average acceleration. Okay. Now what's given? It says a Cessna 172 requires 20 seconds. Right, is that like Cessna 172? What is that 172? Is that information useful? No, that's just the name of the, that's something to do with the model of the plane, right? So don't let that 172 distract you. So a Cessna 172 requires 20 seconds. So a time is given there. What is that? 20 seconds? You need a variable. 20 seconds to reach liftoff speed of 120 kilometers per hour. So it's lifting off. So this plane, it's here. We're assuming it's at rest. And it goes down the runway, and it has a final velocity before it takes off. And so that 120 kilometers per hour, that is our final velocity. And in reasoning this through, we see that, okay, well, it takes 20 seconds to get to the takeoff speed. It's not telling us that it's starting at any initial speed, so we're going to assume that it starts from rest. And what else does it say? That's all the information it's given. And it's asking for the average acceleration. So then, what equations are relevant? Well, I think here, we do the definition of average acceleration, change in velocity over change in time, equals v final minus v initial over t. Okay. So now, this equation is kind of already solved for us for average acceleration we're looking for. So let's rewrite it. We know v final, we know v initial, and we know t. But there's a problem. Our velocity is given in units of kilometers per hour. So this numerator is going to have units of kilometers per hour. Time is given to us in units of seconds. So if we just find a difference in velocity, 120 minus 0, which is 120 kilometers per hour, we can't just simply divide it by 20 seconds because we don't have consistent units. We're dividing a number that its time units is hours by a number whose time units is seconds. So we got to convert units. And so the standard for acceleration is meters per second squared. So I'm going to go ahead and convert acceleration to, velocity from kilometers per hour to meters per second. Now, if you converted time to hours and found the acceleration in units of kilometers per hour squared, is that incorrect? No, it's not. It is the acceleration, just in units of kilometers per hour squared. though those are unconventional units for acceleration. We don't typically use kilometers per hour squared. So that's why I'm converting the speed from kilometers per hour to meters per second to be in a more, our conventional units of meters and seconds. So first, I'm going to take 120 kilometers per hour and convert it to meters per second. So there's 1 kilometer is 1,000 meters, and 1 hour is 60 seconds. So kilometers cancel out, hours cancel out, and I'm left with 120 with 3 zeros, 120 times 1,000 divided by 60. This is units of meters per second. Okay, so this is basically gives me 1, 2, 3. So 6,000 meters per second. Is that correct? I can check my mental math. So 120,000 divided by 60. 12 divided by 6 is not 6, it's 2. Yes, good thing I checked it. I don't know. When it makes mistakes, it's good to check your work. Case in point. Alright, so that's our final velocity in units of meters per second. So I want to stress, this is the same as that. Right? It's the same speed. Just one, it's reported in kilometers per hour, and here it's reported in meters per second. So I can go over here and write this as 2,000 meters per second. So now, select the equation, solve. It's already solved for acceleration. 2,000 meters per second minus 0 meters per second divided by 20 seconds. I'm going to get 200 divided by 2 is 100 meters per second squared. Okay. Circle my final answer. Does that seem reasonable? To be honest, I don't know. I don't know what the acceleration of a plane is, but if I look, if I'm going from 2,000 meters per second over the course of 20 seconds, I'm going to have to be increasing my velocity by a decent amount every second. So I think it seems reasonable. 100 meters per second squared. So that is the answer. That is the average acceleration that the Cessna 172 requires.